All right, let's jump right in. Today, we're going to pull back the curtain on one of the most talked about and maybe misunderstood technologies out there, Bitcoin. Forget the hype, forget the price charts for a minute. We're going to see how this thing really works, from the ground up. So let's start with a huge question, really the core idea behind it all. What if you could actually be your own bank? I mean, no company, no government, nobody in the middle, just you and your money. That's the big promise of Bitcoin. But to pull that off, it had to solve a really, really old problem in the world of computers.
Think about it like this. If I hand you a $10 bill, that's it. The transaction's done. I don't have it anymore, and you do. Simple, right? But online, it's different. Sending digital money is more like sending an email. I can send the same file to 100 people. So how do you stop me from sending that same digital $10 bill over and over again? Well, that's why we have banks. They're the ones keeping track for us. But that leads to a problem known as
the double spending problem. For decades, this was the big hurdle for creating true digital cash. The only way around it, we thought, was to have a trusted third party, like a bank, keeping one central official list of who owns what. Bitcoin's genius was figuring out how to solve this without that middleman.
And this is where we get to Bitcoin's truly radical solution. It's not just a new kind of money. It's a completely new way of thinking about how to prevent that digital cheating, all without a central authority.
These are the words from Bitcoin's mysterious creator, Satoshi Nakamoto, and that last part is everything, based on cryptographic proof instead of trust. It's a massive shift. We're moving from a system where we have to trust institutions to a system where we only have to trust math. The proof is right there, in the code, for everyone to see.
And the technology that makes it all happen is, of course, the blockchain. Now, the best way to picture it is just like this. It's a shared public ledger, kind of like a magic notebook that can never be erased. It's distributed, which just means thousands of copies exist on computers all over the world. Because everyone has a copy, everyone can work together to make sure it's always accurate. No single person or company owns it. Okay, so we've got this magic book. But how do the pages get written? Let's break down exactly what happens when a transaction goes from your keyboard into that permanent, unchangeable record.
So it all starts with you. First, you decide to send some Bitcoin. You create that transaction, and you sign it with your private key, which is basically a super secret password that proves you're the real owner of the funds. Next, that signed transaction gets blasted out to this huge network of computers. And then, finally, computers on the network, which we call nodes, start grabbing all these valid transactions and bundling them together. And that bundle of transactions is what we call a block. You can think of it as one single page in that giant public ledger. A new page, a new block, gets added to the book about every 10 minutes, packed with all the transactions that happened in that time frame.
Now here's where things get really, really clever. To keep things running smoothly and efficiently, you don't actually cram the full details of every single transaction into the block's main summary. Instead, you use this brilliant trick called a Merkel tree. All the transactions are put through this process called hashing, which just turns them into a short, unique string of text. Then those hashes get hashed together, and so on, over and over, until you're left with just one single hash. That final hash, the Merkel root, is like a unique digital fingerprint for the entire batch of transactions.
And this is what puts the chain in blockchain. Every new block that's created includes the unique fingerprint, or hash, of the block that came right before it. This creates this incredibly strong, unbreakable chain. If anyone tried to go back and change even one tiny detail in an old block, its fingerprint would change, which would break the link to the next block, and that would break the link to the one after that, and the whole network would immediately know something was wrong.
So this system is unbelievably secure. But it brings up a huge question. If there's no CEO, no company, no one in charge, how does this massive global network of total strangers decide which block gets added next?
Right? How does everybody come to an agreement, what we call a consensus, about what the true history of transactions actually is? This is probably the most important part of Bitcoin security. And the answer is a process called proof of work. You can think of it like a giant, continuous competition. These participants, who we call miners, use incredibly powerful computers to try and solve a very, very difficult math puzzle. The first one to find the solution wins the right to add the next block to the chain. And doing that work costs a ton of real-world electricity, which is what anchors the digital chain to the physical world and makes it so secure. So let's break down the two main players here. On one side, you have the nodes. Think of them as the referees.
They all have a copy of the blockchain and the rulebook, and their job is to check every transaction and every block to make sure no one's cheating. Then you have the miners. They're the contestants. They do everything a node does, but they're also competing in that massive race to solve the puzzle and create the next block.
But why would anyone spend all this money on computers and electricity to do this? Well, there's a very big incentive. The winner of that race, the miner who solves the puzzle, gets rewarded with a batch of brand new Bitcoin. Right now, it's 6.25 BTC. This reward is actually how new Bitcoin are created, and it's what pays for the entire security of the network.
So, when it's all said and done, what's the one rule that keeps everyone honest and on the same page? It's simple. The longest chain wins. The network will always accept the version of the blockchain that has the most proof of work, the most energy invested in it. To cheat, you'd have to redo all that work and outrace the entire honest network combined. It's just practically impossible.
And that's why your transaction gets safer and safer over time. As soon as your transaction is included in a block, that's called one confirmation. When another block gets built on top of that one, you have two confirmations. The more blocks that get piled on top, the deeper your transaction gets buried and the more secure it becomes. Once you get to around 6 confirmations, it's considered rock solid.
Okay, so we've dug deep into the how. It's an amazing piece of engineering, for sure. But let's zoom out. So what? Why does this all matter?
I love this quote because it really nails it. Think about it. We have public infrastructure for information. We call it the internet. But until Bitcoin, we only had private roads for sending value online, roads owned by banks and credit card companies. Bitcoin built the first public highway for value, open for anyone to use, anytime, no permission needed.
And that creates a totally different kind of foundation. Traditional systems force you to trust a few big companies and their private servers, which, by the way, can be hacked or shut down. They're single points of failure. Bitcoin's system is decentralized. There is no central server to attack. The trust isn't in a company, it's an open source math that anyone in the world can check for themselves. And what's really fascinating is that these core ideas, this decentralization, this unchangeable record, are now being explored in areas far beyond just money. People are looking at this for things like tracking products in a supply chain, securing healthcare records, building more trustworthy voting systems, even creating digital tokens for things like real estate and art.
You know, it all started with this elegant solution to the double spending problem. But what it really did was unlock a completely new way to organize ourselves, a way based on shared agreement and math, not on a central boss. And that leaves us with a pretty incredible question for the future. If we've built this global public system for value, what other parts of our world that rely on middlemen are about to get a major upgrade?